that foreign network IP address, that and all comes under mobile IP. So it results in the active sessions of the device being terminated. Mobile node is moving from home node to home network to not maintain sessions properly, that session will happen. So in this case, that if mobile node moves into the foreign networks also, one mobile IP address should get allocated, that packet data transmission should happen properly. This is our ultimate goal. And mobile IP was created to enable users to keep same IP address while traveling to a different network. Mobile IP technology is enabled while we're traveling from home network to foreign network also, to maintain the same IP address. That particular ends creating through mobile IP. See, even can be on a different wireless operators. It can be different wireless operator, but the same IP address we are maintaining. Like this, this mobile IP standard is adding advantage, ensuring that a roaming individual continue communication without termination these sessions. This roaming mobile entities could continue the sessions without terminating communication sessions or being dropped, we can say. Because the mobility functions of mobile IP are performed at network layer. The mobile IP functionalities all are performing at network layer. All the functionalities comes on the network layer only, rather than the physical layer. We are not going to work anything with physical layer or transport layer. All the mobile IP functionalities are working in network layer. The mobile devices can span different types of wireless and wireline networks while maintaining connections and ongoing applications. We are using ongoing applications. We are using several connections. It may be between wireless and wired networks all together come into the picture. See, we can say some good examples for mobile IP networking. We are logging some sessions and we are utilizing those sessions. Means user is moving from one place to some other place while doing this session. That is one example for mobile IP. And file transfers, while in roams time, file transfers or video usage between two mobile nodes. These are all examples for mobile IP. While we are doing these sessions, our ultimate goal is without interruptions in communications, how mobile IP works. So certain network services based on IP addresses only, changing these IP addresses could compromise the networks. Means if we don't have standard mobile IP from while changing from one network to other network, some features could compromise if we don't have one specific mobile IP standard. That is the problem we will face otherwise. Now we will see what are the components present in the mobile IP network. Then we will get the clear picture. What are the components present in the mobile IP networking? See, mainly mobile IP has three components. One is mobile node, second is home agent, third is foreign agent. First is mobile node, second is home agent, third is foreign agent. Only three components we have in mobile IP networking. And we will see that mobile IP components and relationships, how it is equipped in the mobile IP network architecture. Okay, just I will explain without drawing any diagrams. You will get it, no problem. See, we are having one mobile node. Mobile node is nothing but a cell phone or laptop, which is that software enables network roaming capabilities. Mobile agent or mobile node is nothing but a cell phone or laptop that software enables network roaming capabilities. This is called mobile node. We are having one mobile node and home agent. Mobile node home agent. Home agent nothing but a home router, and it is connected with the internet, and internet is connected with the foreign agent. Internet is a set of home agents. Through that, several mobile nodes are connected. Now, how the communication is happening in the mobile IP networks. See, the home agent is nothing but a router on the home network serving as a anchor point for communication. Home agent acting as a router serving to foreign network with mobile nodes. It tunnels packets from a device on the internet, and this home agent, or you take a foreign agent, it tunnels the packets between two mobile nodes by using the uh, various components in the architecture like home agent or foreign agent. A tunnel will be established between the home agent and reachable point for the mobile node. Reachable point for the mobile node. That is, we can say it is in the foreign network. It is in the foreign network. Here, home agent, foreign agent are working to transfer the packets from home mobile node to foreign mobile node. That is architecture. If we see once again in the architecture, the main components are mobile node, home agent, foreign agent. Home agent is nothing but a router in the home network. Foreign agent is nothing but a router in the foreign network. Between this mobile node, home agent, and foreign agent, and that foreign mobile node, these tunnels are establishing and transmitting without any interruption in the communication. This is how this overall architecture is working. Now, if we see foreign agent is delivering packets from the home agent to the its mobile node. We can say for foreign agent, it's a visitor mobile node. Foreign agent is delivering packets from home mobile node to foreign mobile node by using these tunnels. This is what the architecture in mobile IP networks. Yesterday, I have shared one PPT and two documents. Now, right now, I don't have PPTs. That's why I'm not able to share. Anyway, they have uploaded. Please take some uploaded point. And next concept we'll discuss like how mobile IP works exactly. Okay. So in mobile IP processing, mainly three steps are involving. One is agent discovery. Means mobile node, it has to discover to which mobile node it has to communicate. For that mobile node related foreign agent, home agents, it has to identify. This is called agent discovery. And second is registration procedure. The mobile node registers its current location with the foreign agent and home agent during the registration. Registration process is nothing but the mobile node location address registers with the home agent and foreign agent during the registration procedure and tunneling. See, a tunnel is a setup by home agent to the care of address is nothing but a it roams from home network to foreign network. When it enters into the foreign network, that foreign network is allocating one IP address that is called care of address. We are calling it as care of address. See, tunneling is nothing but a it's a setup by home agent to the care of address through the foreign agent to route packets to the mobile node. Simple, we can say tunnel is between home agent and foreign agent and visitor mobile node to route the packets from home agent to foreign agent to uh, visitor mobile node. This is tunneling and registration I told and agent discovery. Totally we have 3 steps in mobile IP networking. 3 phases we have exactly. One is agent discovery. Second one is registration procedure. Third one is tunneling. That time it has to identify the foreign agents while roams uh, without having that communication without having termination in the communication session. That is the main phase, agent discovery. I will go briefly about the agent discovery and registration. Second, mobile node has to register its IP address with the home agent and as well as foreign agent while roaming time. It comes under registration procedure. Third one is, and briefly I will go step by step how this registration procedure is happening. If registration procedure won't happen, what will happen? Step by step I will explain later. And third is tunneling. Tunneling is nothing but a uh, communication session between home agent and mobile node and foreign agent and visiting mobile establishing by using tunnel IDs and IP addresses that IP packets are transferring end to end. What tunneling session is doing. Now we will see steps in agent discovery, exactly what is happening and all. See, during agent discovery phase, the home agent and foreign agent advertise their services on the network by using the ICMP router discovery protocol. During agent discovery phase, what is happening? The home agent and foreign agent advertise their services on the network by using the ICMP router discovery protocol. We are having one IRDB protocol. It works in network layer only. By using this protocol, the home agent and foreign agent always advertises its services in the network. The mobile node listens to these advertisements for a network. If that mobile node is listening that advertisement, it comes to know whether it is in home or foreign network. That mobile node easily able to understand. Carry mobile IP extensions that specify whether an agent is a home agent or an agent or both. See, through that IRDP IP addresses extension, whether that mobile node is a foreign node or a foreign mobile node or a home mobile node, it comes to know. Or both, that home is agent itself, the home agent itself sometimes act as a foreign agent. At the time, home agent and foreign agent is that router only. Uh, that mobile node is enter into the foreign network with the same router. Like this also, we have the procedure. The IRDP protocol provides type of service, which type of service it's providing, such as reverse tunneling or normal routing encapsulation, whether it's able to provide or not, the allowed registration lifetime, roaming period for mobile node. These all parameters are providing this IRDP type of services. It comes under all parameters comes under type of services. I am providing these all services to you. The list of services it will provide to the mobile node through IRDP protocol. So mainly in agent discovery, the IRDP protocol is working. It comes under networking layer. Here it's giving it's advertising this type of services. What are the services I'm able to provide? Means I'm able to provide reverse tunneling or not, or I'm providing only normal tunneling, or I am able to provide this GRE routing, Jntuk routing encapsulation. The encapsulation of the packet, decapsulation of the packet, I am able to provide or not. The registration time it's providing, and a roaming period for visiting mobile networks. How much duration I am able to provide, how much session duration able to provide visiting mobile node. These all parameters is providing by IRDP protocol. So here what is happening, mobile node can also initiate its own advertisement without waiting for home agent advertisement or foreign agent advertisement. Rather than this, mobile node also can advertise itself. A mobile node can send out requests. The request forces any agents on the link to immediately send an agent advertisements. So before sending advertisements through home agent or foreign agent, the mobile net itself requests request sends in the network. Please send any advertisement to me. Like that, it is also able to initiate the request. If a mobile node determines that it is connected to a foreign network, if a mobile node can comes to know through those advertisement it is in the foreign network, then that care of address is allocated by the foreign network only. Means when roams from home network to foreign network, that mobile IP, same mobile IP is allocated by the foreign network. It's called care of address. Just a second. Here we are having types of care of addresses. Care of address is supporting by foreign agent, or care of address is supported by the foreign network, or co-located address. Second one is that IP address is allocated by the home network only. That care of address is allocated by the home network only. Care of address is supported by the foreign network. That is one thing. And the co-located IP address that is allocated by the home network only. Two kinds of care of addresses we have. If mobile node care of address acquired from a foreign agent, the IP address can share the address with the other mobile nodes. See, if the IP address for the mobile node acquires from the foreign network, that same IP address we can share with the other. If that care of address allocated by home network only, that particular IP address we can't share with the any mobile nodes. This is the thing happening in the home network and foreign network. Care of address is allocated by foreign network. Then we can share that IP address with other mobile nodes also in the foreign network. If that care of address is allocated by only home network, in this case, we can't share that IP address mobile nodes in the home network. This is what care of address constraint we have. And when the mobile node hears a foreign agent advertisement and detects that it has moved uh, outside of home network. You see, now mobile is roaming from home network to foreign network. It hears the advertisement from the foreign network. Then immediately it will start the registration procedure. It has to register with the home agent and as well as the foreign agent. This is how this registration procedure is happening. Means once this full-fledged completion of registration procedure only, that communication system without interruption happening. Now the mobile agent enters into the foreign network. How it comes to know it enters into the foreign network? By listening that advertisement. Then it will start immediately registration. By listening those advertisement, it got allocated care of address with the foreign network. Now this is all comes in agent discovery. The next step is registration procedure. Okay, we will see now how the registration procedure is happening with respect to mobile node to the home network and foreign network. The mobile node is configured with the IP address and mobility security association also there. Mobility security association in the sense it will have one IP, it will have one shared key. That is for security purpose we are using that security key. Now mobile node having IP address and shared key. Those two are provided by home network initially. In addition, the mobile node is configured with either its home IP address or another user identifier, such as a network access identifier. In addition to this, mobile node is get equipped with the network identifier also. And here the first thing is in registration procedure that it is equipped with the IP address of the home network and one security key, that is a shared key it have, and for another identification network identifier also we have going to do by using these parameters in the registration procedure. The mobile node uses this information along with the information that it learns from the foreign agent advertisement to form a registration request. Mobile now forms the mobile registration request, mobility registration request. In this, it is using the foreign network advertisement details also, and from home network what are the details it have, and from foreign network what are the details it equipped. This, by combining these two details, it will form the mobility registration request. So in this case, how exactly this mobile node is forming the mobility registration request? See, mobile node sends the registration request to its home agent, either through the foreign agent or directly. Uh, Means if that router itself is acting as a foreign agent, through that router only, it will send to it will it will send it. Here we may have the chance of foreign agent, or that home agent itself act as a foreign agent. Mobile node sends the registration request through, suppose let us take example, foreign agent is present. This mobile node sends that registration request to an agent. See, here the main thing is it have care of address. By using care of address only, it is sending that registration request. If the register request is sent through the foreign agent checks the validity of the registration request. See, now that mobility node is a visitor mobility node for that particular foreign agent. That visitor mobility node is sending registration request through foreign agent. When foreign agent receives the registration request, it will check the validity of the registration request first. The one time duration will be there. The registration is available or not. The requested tunnel means whether it is a normal tunnel or a reverse tunneling mechanism. And this agent also will, this foreign agent also will check whether I'm able to support to this reverse tunneling, or this kind of all checking mechanism will happen when it receives the registration request from mobile node. First thing is when foreign agent receives the first thing is when foreign agent receives the registration request from visible from roaming mobile node, is a visitor mobile node. It will check the timestamp of that registration request, whether that is valid or not. After that, whether it's a normal tunnel or a reverse tunneling, whether I am able to support or not. This kind of parameters, all this foreign agent will check. Now, foreign agent, what it will do, if the registration request is valid, the foreign agent visiting mobile node to its list before sending that request. That registration request is valid means it will add in this visitor mobile node list before sending that request to the home agent. First step, it will do this one. If the registration request is valid, the foreign agent sends a registration reply with the appropriate error code. If that registration request is not valid, then it will send an error message with appropriate error code to the visitor mobile node. This is the first step is going to do this foreign agent. Okay, now the thing is that registration request is valid and home agent is sending, sorry, the foreign agent is sending that request message to home agent. That's timestamp and all valid. Here no need to send error at mobile node. So this foreign agent is supporting. It's added in the list. So this foreign agent is trying to send that mobile request message to home agent. That registration of the mobile node address as to register with the home agent and foreign agent. Because of that only this forwarding the same request message to home agent also. The home agent also do the same thing, does the same thing. Here it also checks the validity of the registration request, which includes authentication of mobile node, and it will checks the authentication of mobile node also from that mobile node is valid or not. That thing also at a time it will check. If the registration request is valid, home agent creates a mobility binding. If it's that registration request is valid, then it immediately creates one binding with a mobile node with its care of address and a tunnel to the care of address to end to end with the care of address get one tunnel and a routing for forwarding packets to home address through the tunnel, and it is creating one tunnel in the tunnel table, and through there that IP address tunnel will be there. By using that home address, the home IP address, it is able to forward those packets to that particular mobile node. That type of criteria it will create immediately at home agent whenever checks the validation of the registration request. So we can say one tunnel to the care of address and for forwarding packets in home agent table. These are all facilities is providing at the home agent. Now his home agent is agreeing with the mobile node. It has roams into foreign network. It has roams into the foreign network. Then here by using that registration request, this home agent is agreeing to facilitate all the features. So the next step in this registration, what is happening? The home agent sends a recent reply to the mobile node. It has received the registration request. So for this, it's one. For this, it's sending the registration reply through the foreign agent directly to the mobile node. By using that mobile node address only, it's sending through foreign node. It's sending. If the registration request is not valid, the home agent rejects the request by sending a registration reply with error code, with appropriate error code. Here also the same case. If the registration request is not valid, then it will send the error message with appropriate code by keeping in the registration reply message. So here next step is what is happening. Foreign agent checks that registration reply message, validity of registration reply message. Here also it will have one timestamp, whether that timestamp is exceeded or it is within the timestamp. In that registration reply message also, the foreign agent first it will check. And if it is valid, the foreign agent adds the mobile node to its visitor list, establish a terminal to the home agent, and that registration reply message is valid from the home agent, and by C that visitor mobile list already added in the table. By retrieving that particular visitor mobile node, it will try to establish the tunnels with the home agent. Now that it is also ready to forward those packets to home agent. And this foreign agent also creates the routing entry. Routing entry is nothing but a IP address and that tunnel ID. In the table it will create for forwarding packets to the home address. Then this foreign agent registration reply, that this foreign agent that registration reply forwards directly to the visitor mobile node. This registration request is initiated by mobile node, and finally this registration is got received by the mobile node. Finally, mobile node accepts the registration reply. The mobile node is confirmed that the mobile agents are aware, it's routing. See, mobile node is receiving the registration reply. After receiving this registration, mobile registration reply, the mobile node comes to know that, okay, here home agents and foreign agents are supporting to me for these communication sessions, and it all knows about me, these tunnels and all. These tunnels and all properly established for communication sessions. It's like a acknowledgement. It got mobile node got that registration reply. Then home agent, mobile node, foreign agent. We have home agent. Between these three components, tunnels are established. Now we can say that packets forwarding in tunnels is ready without having any interruption in the communication sessions. That's why I said previously also, in mobile IP networks, mainly we have three components: mobile node, home agent, and foreign agent. Through this only, the communication sessions without having interruption, it's establishing by using this mobile IP mechanism. Just a minute. If we see overall points in the registration procedure, once again, the first point is the mobile node is equipped with the IP address and foreign agent details and all. With these details, this mobile node is trying to send the mobile request message to the home agent. In this process, whenever mobile node sends this mobile request, first it receives by foreign agent. It checks the mobile request validity, timestamp, whether it's a valid or not, whether that timestamp is valid or not, and it will check its own types of services with respect to mobile node, whether that mobile node is supporting with the encapsulation and reverse tunneling also, whether this router is able to support or not. These all will check. If it is not in a position to support for mobile node, that time itself it will send with the error code messages and all. If it is in a then that mobile request message will release to the home agent. This is first step is happening in the registration procedure. So the registration request is sent to the foreign agent. The foreign agent checks the validity of the registration request. The request tunnel encapsulation is available or not, and it is supporting to GRE protocol, that routed protocol supporting or not, and it's all checking, and it's giving that request message to home agent. The home agent also checks the validity of the registration request, whether within the time this request is coming or not. Which then first it will check the authentication of the mobile node, whether this mobile node is valid one or not. It can check. Why means from home network only it roams by using that IP address, whether the authentication of the mobile node is valid or not. Registration request finally is valid. The home agent creates the mobility binding. Mobility binding in the sense mobile node with its care of address. That IP address it will maintain in the table, and a tunnel ID. For that IP address, a tunnel ID is maintaining in the table, a tunnel ID to the care of address. And now it's in a position to route the packets for particular mobile node. So the home agent sends a registration reply message to mobile node, the foreign agent, only, directly to the mobile node. If the registration request is not valid, the home agent rejects the request with the appropriate code. And foreign agent also checks whether that registration reply to mobile node is valid or not. If it is valid, the foreign agent adds the mobile node to its visitor list by retrieving the visitor mobile node in the list. It will try to add that reply message also to that visitor mobile node, and it also establishes with the visitor mobile node. And now this foreign agent also uh, is ready with the routing table that while visitor mobile node IP address and that tunnel. Now it is able to route the package to that particular visitor mobile node. Finally, that mobile node accepts the registration reply. The mobile node is confirmed that the mobile agents are supporting to me, and these tunnels are established between home agent, foreign agent, and visitor mobile node, and it comes to know that, and the tunnels are established. Now it's in a position to communicate the session without having any interruption. This is how this registration procedure is happening. Here we have one failure case, like in case where the registration is denied because of time mismatch. So whenever this mobile node is sending registration request to foreign agent is sending to same request to home agent, some timestamp mismatch is happening. That time this foreign agent or home agent can't support for the registration request. It's a failure case. We have like registration is denied because of time mismatch. The mobile node makes the necessary adjustments. The mobile necessary adjustments based on that replies with the appropriate error code it's receiving, right? Foreign agent or home agent. This timestamp is elapsed. You use this particular timestamp like that. It will try to adjust the mobile will try to adjust the timestamp, and it will try to initiate the it will try to initiate registration request, the same registration request to the foreign agent and home agent. Means we can say that the registration attempts, the process will start again. Finally, successful mobile IP registration setup is established between home agent, foreign agent, and a visitor mobile node. And this routing mechanism is established between home agent, foreign agent, and a visitor mobile node without having any communication session interruption. For we can say now we can comfortably transport these packets to end to end, between home network and foreign network, from mobile node to mobile node. This communication session is established and full-fledged. This is what registration procedure happens. We have discussed first two phases of mobile IP networks. That is, first one is agent discovery. Second one is uh, registration procedure. Two phases in mobile IP network. Mobile IP network communication we have seen. The third step is tunneling. How it's happening and all. Just give me 2 minutes. I will just back. Now we will see about the tunneling mechanism between source mobile node and home agent, foreign agent, and visitor mobile node. The tunnels are established. Now that packet forwarding by using this and reverse tunneling mechanism, how it's happening. Now step by step we will see this tunneling mechanism, how it works and all. First, the mobile node sends packets using the its IP address, and it is roaming to foreign network. Mobile node is sending these packets through by using IP address, and it's sending through it's it's sending through home agent and foreign agent to the visitor mobile node. So here, home agent wise, we have visitor mobile node IP address and the tunnel ID. The same thing in foreign agent of source mobile node, that packets are coming. Just just home agent agent, it will retrieve the IP address and tunneling ID. It will try to forward those packets to the foreign agent. Foreign agent, it will retrieve the IP address and tunnel ID, particular tunnel ID, and it will try to forward packets to visitor mobile node. This is what tunnel mechanism is happening end to end in mobile node, home agent, and foreign agent, and visitor mobile node. You see, if we take this tunnel mechanism, we are encapsulating the packet while forwarding. At the initial stage itself, we are encapsulating while entering into the tunnel. Any component, from any component we can consider source mobile node or home agent or foreign agent or visitor mobile node. From anywhere while sending at the starting of tunnel, we are encapsulating the packet at the receiving end. At receiving entity that decapsulate the packet through that tunnel, and it will try to send it will try to get the IP address and the tunnel ID, and it will try to forward packet to the final destination. This is what happening in the tunneling. Here we can say it's a purely IP encapsulation, and inside optionally this generic routing encapsulation also will perform. It's a GRE protocol. Optionally inside encapsulation we can do this GRE encapsulation also, generic routing protocol encapsulation, and we will see about reverse tunneling mechanism. Means source mobile node, home agent, foreign agent, and visitor mobile node. Totally 4 components we have. From source mobile node to visitor mobile node, we are forwarding the packets by using this tunnel mechanism, and from visitor mobile node, it will try to forward the communication packets to the source mobile node. It's using the reverse tunneling mechanism. How it's happening? This mobile node also equipped with the IP address and tunneling ID, visitor mobile node also. The same thing, it will encapsulate those particular communication packets at visitor mobile node, and it will try to send the foreign agent. Foreign agent will decapsulate those particular packets. It will identify the next destination IP address, and it will get the tunneling ID also, and it will try to encapsulate to send. And like this, later it will receive by home agent, and home agent will send those packets to the home agent. Sends those packets to the uh, source mobile node. Documents yesterday itself we have uploaded 3 PDFs. I don't have any specific PPT to share now. Just please download those PDFs you can get these all concepts. And okay, I will continue my session. Now we will see reverse tunneling. You see, now in mobile IP network we have source mobile node and home agent, foreign agent, and visitor mobile node. Now that visitor mobile node is sending packets to the source mobile node. It also have its own tunneling table. It will get the IP address and the tunnel ID. It will try to send the packets to particular tunnel by encapsulating the packets. And those packets will receive by foreign agent. Foreign agent will try to release the source mobile node. This is what tunneling mechanism, tunneling and reverse tunneling is happening in mobile IP networking. Security in this packet communication, security concepts and all you will see in later session. Today we have seen up to topics like IP, how it works for mobile IP networking. Based on IP address only, everything we are doing in the mobile IP networking. That is first thing we see. And packet delivery, encapsulating, decoupling, tunneling mechanism, how it's happening, we see. And from home network to foreign network, how the mobile node is enters. And that time, how this location management, registration procedure, tunneling procedures, and encapsulation procedures happen up to these concepts we have seen today. And security procedures and all in next session we'll see. If we once again cross check all the points from top to bottom of this mobile IP networking, first thing is the purpose of mobile IP. Mobile IP is introduced by IETF, Engineering Task Force. The purpose to introduce mobile IP is while roams from one network to other network, from Wi-Fi network to mobile, or mobile network to Wi-Fi network, or wired network, anything from one network to other network, while roams, we are maintaining one standardized mechanism, that is mobile IP. That is mobile IP standardized mechanism. And while moving, we are facing the problems at the data link layers. Some constraints we have. Network-wise, we will have only certain services. Some networks-wise, we will have only some facilities. Data link layer-wise, we are facing some challenges. To overcome these all things, mobile IP come into the picture. Now, if we see mobile IP overview in second step, we can say this routing of packets is always based on IP packets only. Similarly, how this postal department is work based on address on envelope. This envelope is reaching the final destination. A device on a network is reachable through normal IP routing only. It's always by using IP is happening. And the thing is, the problem occurs when a device roams away from its home network and is no longer reachable using normal IP routing. This results in the active session communication may terminate. Without termination, this active session of communication, this mobile IP is working. And if we see components in a mobile IP network, the main three components are mobile node, home agent, and foreign agent. Means by using these three components only, this communication end to end is happening in the mobile IP networking. Mobile laptop that software supports roams in a network. Home agent is nothing but a router on the home network serving as the anchor point for communication with the mobile node. And it tunnels with the foreign agent and the mobile node for transmitting the packets. Like same foreign agent also is a router in foreign network. It tunnels it delivers from the home agent to the mobile node. That is how foreign agent is working. These are the three components in mobile IP networking. Now we will see how just basic steps, one or two, three steps we will see. Again recapturing these same points. How mobile IP works now we will see. Here I said 3 pages it will work. One is agent discovery. The second is tunneling. And the third one is registration. Through these 3 pages, this mobile IP communication is happening. The first step is agent discovery. A mobile node discovers its and home agents during agent discovery. That I already explained step-by-step procedure how this agent discovery is happening. That overall in agent discovery, so what is happening? A mobile node discovers its home agents and foreign agents in discovery registration. The mobile node registers current location with the foreign agent and home agent during the registration procedure. We have seen the overall steps in the registration procedure. If registration fails, what will happen? If in the registration requirement elapses, at that time, what are the actions is taken care? These are steps we have overall 3 pages. This mobile IP network communication is happening. First step is agent discovery. Second step is registration procedure, and third step is tunneling. A tunnel is set up by home agent and foreign agent between source mobile node, home agent, foreign agent, and visitor mobile node. This tunneling is established for route packets to the mobile node. And if we see basic steps in agent discovery, the mobile node listens the advertisement from home agents and foreign agent. It will try to stop the home agents and foreign agents, and it roams into the foreign network. It got allocated with the care of our home agent itself will allocate co-located address of IP address. Means here we can say IP addresses types. Two types of care of addresses exist. Care of address acquired from the foreign agent, that is first thing, and co-located address from home agent. Co-located address is nothing but home address is allocating that IP address. Two types of care of addresses. This is all comes under agent discovery. These are all main points in agent discovery. If we take in registration procedure, the mobile node is already configured with the IP addresses and types of services, and the mobile node already equipped with the foreign network services. So by combining all these, it will try to create the registration request. Registration request first sends to the foreign agent. Foreign agent, it will check whether it's a valid one or the duration and the types of service I'm able to support or not. If it is able to support, then it will try to add that one in a list, and it will try to forward that registration request to home agent. Home agent also will try to check the validity of the registration request, and at the same time authentication mobile node. It will check and it will try to the in its list, and it will try to create the tunnels between source mobile node and home agent, and it will just reply back with the registration reply, and the same registration reply is also checking at the foreign agent whether it's a valid one or not. If it is valid, it's foreign agent and home agent two-way two-way communication. So tunnels are established. And we can say that mobile node is registered with the home node, and that mobile node is registered with the home agent and foreign agent. This is how happens in the registration procedures. In case where the registration is denied because of time mismatch, the mobile node makes the necessary adjustments based on a home agent timestamp. If that timestamp elapsation picture that registration request is denied, then based on suggestions by home agent or foreign agent, it will to modify that timestamp. It will try to attempt the registration procedure once again. Finally, by doing the same steps, it will get complete. It will complete the registration procedure. A successful mobile IP registration setup is completed between a home agent and foreign agent mobile node. We can say finally, and this tunneling we see mainly the tunnels will establish. If we focus on tunneling, the tunneling is established between source mobile node, home agent, foreign agent, and mobile node. And while transmitting the packet, encapsulating and decapsulating mechanism will happen. And it is we can say it's a purely IP encapsulation. GRE, we have one more protocol, GR generic routing encapsulation. It's not protocol, it's a encapsulating mechanism, generic routing encapsulation. It's we can use this encapsulating mechanism optionally in IP encapsulation. While packet forwarding in tunnels, it will just be address and that particular tunnel ID, it will try to forward those packets. Like this only, reverse tunneling is happening. While reverse communication, it will try to get the IP address of the source mobile line, source mobile, and the tunnel ID, and it will try to forward those packets to the source mobile node. This is how this reverse tunneling mechanism is happening. The overall procedures we completed are IP network layer mechanism, so the IP role in the mobile IP networking, and second thing is how exactly mobile IP works. That is second step we covered, and the third step is in mobile IP communication phase, three phases we have mainly: agent discovery, registration, tunneling. These procedures we have covered, and in next session, these security-wise procedures we will cover. This is what today's my session. Any queries? Can you communicate? Can you chat with me? Here, Jntuk Moocs is typing or sharing any PPT. I don't have right now any PPT, so just I uploaded three PDFs portal. Please download those PDFs only. Getting information what I have